This is video 2 for paper 3 of the mock exam. Here we are looking at loci and constructions. What it wants us to do on this graph is to construct a line on the map to show all the places where the treasure could be buried. In order to do that, what we need to do is a perpendicular bisector. Now, in order to do that, you will need a compass to do this and a ruler. Without a compass, what I will do is just try and show you how you would go about doing it. If you take your compass and set it so that it is more than half the distance between the two lines, so in other words, set it so it is a little bit more bigger than half the distance between the two. If you then put the pointy part of your compass on A and draw an arc, you will get something that looks a bit like that, clearly neater with a compass. If you were to do the same and put the pointy part of the compass on B without changing the size of your compass, you would get something, again a little bit neater than mine, that looked like that, giving you two arcs. If you then take your ruler and draw a line that goes through the 2 points where they cross and extends further, going all the way through the diagram, we have got that any point on that line is equidistant from A and B. Therefore, anywhere on this line is where the treasure could be buried. The second question on this topic, loci, starts using different bits of the same idea. So for this one, we have got a map that shows where 3 telephone antennae, the telephone masts, are. What we need to do is follow here 3 different loci. So what we'll do for this one is that anywhere that is less than 4.5 kilometres from A gets telephone coverage. So in order to show where that is, we would look at the scale, set our compass therefore to 4.5 centimetres, put the point of it on A and draw a circle around A that has a radius of 4.5 centimetres. For B, we've got the same idea, but for this one, it would be 3.5 centimetres because it's 3.5 kilometres. So I would do a circle that goes around B, clearly much neater than mine's going to be, for 3.5 centimetres, and then 3 centimetres round C. So we'd set our compass to 3 centimetres, draw our circle, and if you were to draw this accurately, which clearly mine isn't without a compass, you would find that anywhere that is within any of the circles gets telephone coverage. So we have got that on the island, all of this section would receive telephone coverage. Whereas anything off the island, clearly not being on land, and anything outside these 3 circles would not get telephone coverage. The next question is going to be a little bit tricky because some people see shape problems like this very easily and some people struggle massively. Don't worry if that's the case, we can work on this when I return in January. What we're being asked to do here is draw what we would see if we were looking at this object from 3 different directions. If I was looking straight at this shape here from the part A, the only parts of the shape that I would see are the squares that are actually facing me. I would not be able to see around the side, above, or on the other side if I'm looking straight at C from this straight to A from this direction. So all I would need to draw as neatly as I possibly can are these 4 squares here. Looking at the shape from B, so that's this direction, these are the only squares that I would see. I would not be able to see the top, this side, or any other section. So if we look at this, this again forms a little L shape. Try and draw the L in the same direction, same orientation as on the diagram. So we get something that looks like that. From above, so this is from C, we would see these two sections here, looking down at the shape. So we would have two just next to each other. But then we can also see this additional one. So looking down from the top at that shape, you'd see these two, and here just an extra block on top. So that would look something a little like that. The next question we're looking at is to do with a distance time graph. Now you might have seen these in science as well. Here, what we are going to do is start off by describing the first two parts of the journey. Well, this is quite simple. The journey shows that whatever this may be, we'll say it's a person, moves away from the office. That's shown by the fact that you've got a positive gradient, so the line is going up. And then at part B, because time is moving along, but the distance from this office is not changing, that means that they are stationary, so not moving for this bit of time. It then also wants us to calculate the speed for certain sections of this diagram. Well, there's a couple of ways of doing that. Speed is equal to distance divided by time. So because it hasn't specified what time frame it wants the speed in, we can actually cheat a little bit on this one. So for section A, we have travelled in this part of the journey 40 miles. So that's your distance. In terms of time, just be very careful reading the scale. We've got that here 3 squares represent an hour, so each square represents 20 minutes. So here 40 minutes. 40 divided by 40 is 1. So that means you are doing 1 mile a minute. Well, if you can do 1 mile for every minute, that would mean in an hour you will be doing 60 miles. So that is the speed at part A. It wants us to do the same for C. So at part C, it's taken us 20 minutes to travel from 40 up to 55. So that would be 15 miles. 15 over 20, if you type it into a calculator, is 0.7 miles in a minute. But normally we'd change our speed in terms of hours. So because there are 60 minutes in an hour, if I did 60 multiplied by 0.75, that would tell us that we're doing 45 miles an hour for that section of the journey. I'm just going to look at section F now, because we're running out of space with E. This, even though the line is going down, we can still calculate speed. This simply means that we are getting closer back to the office because it's going down. So here again, we have gone from 50 down to 25. So here we've gone 25 miles, and this has taken us 40 minutes. So if you do on your calculator 25 divided by 40, this comes out as 0.625. That again is miles per minute. So timesing that by 60 would give 37.5 miles per hour.